Okay, so we're going to let Team 15 have another try because their motor was off their first try. So we're gonna put Team 15 through. Are we not? Team 15 at the end?
Team 15 at the end.
Okay.
Yeah, no, run Team 12.
Team 12 just ran.
Right.
All right, looks like Team 15's not quite down here yet. So we're going to actually let Team 5 run right now. Hello.
I'm going to change the order, let me know.
Yeah.
Okay.
You want 15 to go next?
Sure, that's fine.
15.
So up right now is Team 5, and so tell us a little bit about your robot.
So our robot has 3 different systems to handle balls. One paddle wheel to collect the balls, and then it's got a screw that lifts the balls, and then a trap door to dump the balls into the goals.
So what was the inspiration behind the screw that you used to raise the balls?
Well, another team was using a screw, so we saw that and it looked pretty cool. And then John, who's over there, did some research on screws, and he found like these things that have balls going down little courses and stuff. And that's what we model our screw after. So we've got 2 bars to hold the ball in, and then the screw turns and the ball goes up.
So it's a very small screw that you're using. Like, how did you design it to be so efficient?
Well, the two support bars really are what help the ball to go up. So I mean, it's just the screw just pushes it up and the bars hold it in. Right now, we're using our exploring round, and what it's supposed to be doing is making a graph of the course with barcodes and goals as nodes on the graph, and then it's going to connect those together.
And is it going to display these nodes on the screen?
No, we didn't have time to make something that would display the graph, but we should be publishing images. I don't know why we're not. 150. It's 150.
So can you tell us about how you recognize barcodes?
Well, basically we just take a small image capture, and then if we see anything that we think is a barcode in the capture, then we change the camera resolution to large resolution, and then just process that part of the image, and then we just take we divide what we think is the barcode up into 5 slots, and then see which each slot, whether it's more green or more black. So what it'll do is it'll go up to a barcode, and then it'll hopefully scan around and see if it sees any other barcodes from that barcode. Right now it's randomly wandering.
So do you have any way of compensating for when you randomly wander and when you're going from barcode to barcode?
No, we didn't figure out how to handle that problem. So if we randomly wander and then discover other barcodes, then that's a disconnected section of the course. So we didn't really know how to handle that.
If you see another section of barcode, though, that you've seen before, will you reconnect the 2 graphs?
Yes, yes.
Now, while you're exploring, are you also keeping track of the mouse holes or the balls?
Yeah, mouse holes are also nodes on the graph. We don't keep track of balls while we're exploring, though. The purpose of the graph was just to tell us where we'd been, just so that we could try to make sure that we covered most of the course. Why doesn't it stop doing me? All right, it should have stopped. I don't know why it didn't.
So it seems that your robot hasn't stopped. Do you know what it's up to right now? Does it think that it's entered the next round, or is it still scanning?
I think it just had a timekeeping problem because it's stopped now. So.
Now, what's your strategy during the scoring round? Are you also looking at barcodes while scoring?
So we pretty much pulled our robot together in the last very short amount of time. So we never managed to test using the graph that we created with the exploring round. So we're not actually going to end up using that. Well, we were hoping to publish some pictures just to show what was happening. Hold on a second.
Yeah.
John, did you hit the right one?
So what's going on with your robot right now?
Well, now it should be just looking around for balls, and then it'll drive towards them. It pretty much just wanders randomly.
So it seems that the paddle wheel in front isn't spinning. And what we're discussing right now is whether the robot thinks that it's in the right mode or not.
It should, because it's going after balls.
So,
Well, it is in the right mode because it's going after balls, but I don't really know why our paddle wheel isn't spinning.
so if you look on the bot client, as they're indicating, well, when we see a ball, wait, is it marking? Sometimes it's marking a ball with a little green dot in the middle to indicate that it's found a ball. So what's the system that's on top of the robot, that curvy shape?
We call that our aqueduct, and what it does is, well, the balls are supposed to go up there, and then they fall down up to the trap door, and then there's a little bar going across on the trap door, and that's supposed to hit the uprights and the goals, and then dump the balls out.
Does that system use any sort of power actuators or anything?
The trap door is completely mechanical. It just has a bar, and it'll dump the balls out.
And what was the inspiration for the design on the trap door?
Well, we had a limited amount of sensors and motors that we were allowed to take. So since we ran out of points for those, we decided we had to have something mechanical up there.
So right now your bot client indicates that it's trying to drop balls. Does it think it found a goal?
Well, after a certain amount of time, it just ignores balls, and then it tries to find a goal. And it seems that it's done that now. Well, I realize a problem now. What we had was we usually try to figure out whether we've hit walls or something like that. But when we're driving towards a goal, we ignore all walls and just drive right into it, because we have to get some pressure on that bar that's going across the top in order to dump the balls out. So I guess what happened was we saw the goal, and there was a wall kind of in the way.